Hello students, in this video we are going to learn about the question number 4 of the EOT. So EOT MCQ question number 4 and the topic is resistors in series. Okay, resistors in series. What does it mean? That whenever the resistors are connected in any circuit, so we need to check that whether they are connected in series or they are connected in the parallel. Okay, so for that case I'm just going to show you some diagrams so that you can understand. As we know, we have the Ohm's law. Okay, Ohm's law. Ohm's law. So as per Ohm's law, what we know, V is equals to IR. Now we need to arrange this resistor in the circuit. Let's say, okay, now we have a circuit with the battery. Okay, let's say this is our battery, positive, negative. And once we start moving, okay, let's say this is the resistance 1, this is the symbol for resistance. Okay, now this is resistance 2, this is resistance 3, and now connect them. Okay, so how do you know these resistance are connected in series? Okay, that is the major point. What you need to understand, there are few rules on which you need to consider. The first rule, okay, that is called plate, or you can say the terminal to resistor. Okay, or in journal term we say positive plate or plate to R. I'll make it easy for you, then you will understand. Plate to resistor. So P to R, first case P to R, second case is R to R, and third case is R to P. You need to understand what exactly it is. Okay, the first thing is same, second thing is opposite, and third thing is same. I will explain this part. Let's say you have the P means plate. We have the two type of plates. We have the positive plate as well as the negative plate. Let's say this is the plate. Okay, this is your positive plate, and for your understanding, this is your negative plate. Fine, plate. Clear? Okay, second point, what you need to understand, resistor. Whenever you are drawing any resistor, it is like this. This is your resistor, but there are two ends. This is your end A, this is your end B. Okay, so these are going to connect. So let's say whenever the plate to resistor, the charge or the value remains the same. I will show you how. This is the positive. Okay, so the current starts moving, and let's say this is the point. So what should be the charge here? Positive. Do you understand? I told you, plate to resistor, the current remains the same, or the charge remains the same, or the sign remains the same. Okay, now R to R, resistance to resistance. So let's say if you're moving from A to B, resistance to resistance, your sign will be opposite. So it will become negative if it is positive here. So here you will get negative. Clear? First point is clear. R to R. Okay. Now we are shifting from R1 to R2. Okay. Now tell me, at R1, what we have? We have negative. So here we will get positive. Do you understand? Because second rule is applied, R to R. Now the other branch, here it should be negative, here should be positive, here should be negative. Clear, guys? So from here, negative. Now this is your R. You are moving towards plate. Understand? R to plate. Value remains the same. Clear? This point, if it is clear to you, then you are able to solve the questions from the series and parallel on the basis of Kirchhoff's rule. All these things, the basis remains the same. Clear, guys? Okay, now how do you understand the given value is a series arrangement or a parallel arrangement? For series arrangement, what do you need to know? For series, whenever you get a circuit, one should be positive, one should be negative. Whenever the other, means the other signs are connected together, that is series. And in case of parallel, same sign, plus with plus or minus with minus. Here, plus with minus or minus with plus. That is the major understanding. I'll show you with the diagram so that you can understand. Okay, let's say we have a circuit here. Okay, and there are some resistors. 1, 2, 3. This you already understand. Plus, minus. Okay, make it big. Plus, minus. So how they are connecting each other? Negative with positive. Negative with positive. They are connecting? Yes or no? Okay, how they are connecting? Negative with positive. It means they are connected in series. Clear? Okay, let's say positive, negative. Okay, here I'll make a circuit. 1, 2, 3. Let's say one resistor, one resistor, one resistor. I'll make it big so that you can understand easily. Okay, just try to understand this part. Okay, once the current is coming from here, okay, let's say change the color. So what will happen? From here positive, from here negative. So here is positive, positive, positive. Clear? Here is negative, negative, negative. So how A and B and C? So just tell me how A and B are connected. They are connecting like this. Yes or no? So A and B, positive, positive. Yes, this is called parallel. This is called your parallel arrangement. Or you can check B and C, how they are connecting, positive with positive. That is your parallel arrangement. Clear? So this is the basic you should know before solving anything in the question. Okay, the second part. In case of series, what exactly we have? See, whenever there is a current, you need to remember with the word spelling also. This is a technique because we have a series I, so I remains same. Always remember this thing. This is very, very important. In terms of series, current remains the same. Always same. It will not change. Okay. So here we have a rule. Let's say we have a total potential. Or I'll make it easy for you. V is equals to IR. Take the circuit plus minus and take two resistors, 1, 2 and connect them. This is your R1, this is your R2 and this is your V. Okay, let's say the current starts moving. So here your positive, negative, positive, negative. Fine. So here it is V1 which is equals to IR1. I told you current remains the same. R2, V2 is equals to IR2. Clear? So how you are going to connect it? So total potential V should be equals to V1 plus V2, which is equals to IR1 plus IR2, which is equals to V is equals to IR. So IR, which is equals to IR1 plus R2. So can I say what is equivalent resistance? R1 plus R2. Clear? Understand? These basics should be clear. before solving any kind of numerical. So guys, go back to the topic. Okay, what we are learning here and on which point we need to put more focus. Calculate the equivalent resistance. So what is your equivalent? I solve for you R1 plus R2, and how many number of, you can say, resistors you have, the sum of all the values. Clear? Okay. For resistors connected in series, as the sum, what I am doing, this is the sum of individual resistance. This is the sum of individual resistance. Clear? And what we are using? We are using Ohm's law. Clear, guys? Okay, so what is the R equivalent? R1 plus R2 plus R3, if we have the three resistors. How to solve the total voltage? That should be the sum. I already solved. You can see here, total voltage. That is the V1 plus V2 plus V3. Okay. Clear, guys? The major thing I told you, current remains the same. Current remains the same. Okay. Last point. Current that flows into the first one is same current that flows out of the last one. Fine. Okay, these are the key points, and might be they can ask you this question in the exam. The total resistance, what is the meaning of total resistance? R equivalent. Remember, R equivalent in series circuit, okay, is greater than the biggest resistance. So R equivalent is always greater than R biggest. How? Okay, I'll give you the example. Let's say you have R1 is 2, R2 is 5, R3 is 10. So can I say out of these three resistance, this is the biggest one? Yes or no? Yes, this is the biggest one. Okay, what should be the R equivalent? R1 plus R2 plus R3. So 2 plus 5 plus 10, which is equals to 17. So can I simply say R equivalent is greater than R biggest? 17 is greater than 10. Yes or no? Clear? Are you sure? Okay. So on the basis of all these information, what we gather now, so the major points are, number one, see the highlighted points. The one, we should know R equivalent, which is equals to R1 plus R2 up to Rn. Clear? This is the first point. Second, R equivalent should be greater than R biggest one. Third, current always I remains same. I remains same. These are the three major points, and you can add one more point. So total voltage should be equals to sum of all the voltages. Clear? These are your learning points. Okay, now guys, time for the questions. Okay, for all the YouTube community, all the YouTube students, guys, so if you want to take the maximum benefit and you should know how to solve these numericals, so you can join my channel and you're heartily welcome. So the link is available and you can join my paid classes. Okay, guys.